I hope you found this course both meaningful and useful. We tried to provide a initially provide a basis for why it is that historically we have been such terrible problem solvers, and following that up with some perspectives on why it is that systems thinking has not been more widely adopted by the population at large, and then providing a set of perspectives as to how to uncomplicate what systems thinking is portrayed to be, and provide a sense of the utility of simply creating relationship maps that help us understand the interactions that are responsible for the way that things are, the situations that we try to figure out how to deal with. From there, we provided a set of content that helped you develop an understanding and a set of skills at developing relationship maps in both Insight Maker and Kumu. And hopefully you did the exercises and created some relationship maps and submitted them and got some feedback to help you become better at creating them. As I said, creating relationship maps is a lot like riding a bicycle. You can get a sense of what it's about by reading about it, by watching the videos. You only develop the skill at creating relationship maps by developing relationship maps. And don't think of it as trial and error, it's trial and learning. The more time that you spend, the more relationship maps that you develop, the better at it that you will get. Now, the final section was to simply provide additional information around how useful it is to think of a model as a storytelling vehicle, and a way to add additional information to a model, a relationship model, by creating causal loop diagrams, which are much more specific, contain more information about the relationships than typical relationship maps do. And the causal loop exercise at the end, you are welcome to create and submit as many causal loops as you would like me to review and comment on, and in that process you will get better at it. The additional parting note is, though, that causal loop diagrams, relationship maps, are static pictures of a set of relationships, and from them we can learn a lot. Though we live in a dynamic world where things are constantly changing, and there are times when we ask questions about relationships that we simply cannot garner an understanding of from looking at a static picture. We need to develop and do simulations to help us understand the implications of those relationships over time, how the relationship unfolds. And to give you a sense of that, I'm going to show you a couple of examples. Here's a relationship between a population of moose and wolves. If I start with a model for a population of moose where the moose have birth rates and death rates, and assign some values to this, the model will say that the moose rate will develop, or the population of moose will develop over 100 years to about 1.3 billion moose, which is a little ludicrous. I mean, one doesn't expect to find that many moose around. Though if we also look at a population of wolves who have a birth rate and a death rate, and we look at what happens with that population of wolves over the same time period, the population of wolves is perceived to die out. Yet when we realize that there's a relationship between the two populations, in that moose have an impact on the wolf birth rate and the wolves have a influence on the moose death rate, when we connect the two of them, something very interesting happens. The two populations oscillate back and forth, which is a pattern that one is extremely unlikely to deduce from simply looking at the relationship map itself in the background. So that's one example. The second one is a simple balancing loop structure where here's the current state and here's the desired state, and that produces a gap which causes an action intended to move the current state in the direction of the desired state. The simplest goal-seeking balancing loop that you could develop, though with one addition in that you can input a time delay between the time that the action changes the current state and you actually realize the implications of that action. So if we run this in the simplest form with no delay, this is the goal. The current state starts at 0 and increases toward the goal over time, and as it does, the gap gets smaller and the amount of action declines. Now, as we increase the time delay, the length of time between the time that the action happens and makes a change and we realize it, we notice that our actions actually overshoot the goal, and we have to take action to bring the current state back to what the goal was. And as we continue to increase the time delay, notice that the behavior of the simple balancing loop gets more and more chaotic until a point where it's absolutely out of control. And someone says, well, what's the likelihood that you end up in a situation where you're not aware of the implications of your actions? Well, think about trying to drive the Mars rover, where it takes 9.5 minutes for you to find out where the rover is at the moment, and when you tell it to turn, it takes 9.5 minutes for your instructions to get there, and 9.5 minutes later after that for you to find out whether or not it actually obeyed your instructions. So it's actually worse than trying to drive looking in the rearview mirror. So this is just a couple of examples to provide you with a sense that there is additional learning in the future about dynamic models to simply add to the value that one gains from developing relationship models to better understand situations and become better problem solvers. So I hope you found this course both interesting and useful. You should be on your way to becoming far more effective problem solvers, and I look forward to seeing you in another course. Take care. Bye.